Hello everyone, it's Lina! So, first dev stream of the year, and I'm going to be back working on the Spout2 lip funnel, that whole story. So if you remember where we left off last stream in at the end of December, we just got Vulkan to work with lip funnel, but actually it's fake working because it's not correct. Because it doesn't have synchronization. So the first thing that is on the list for today is adding Vulkan synchronization to it, which is my first time with Vulkan, but thankfully I actually know quite a bit about how this sync stuff works behind the scenes because I've kind of dealt with it. I've actually written some of the driver code for the Vulkan and EGL driver having to do with synchronization, so thankfully I have some experience with that. So the first thing we're going to do is work on that, and if we have time, which hopefully we will, because I'm kind of hoping this doesn't take too long, we can work on plugging this into Spout2 with Proton and Wine and all those things and see if it actually works. So let me say hi to people. Also, I got a new GPU. The stream computer now has an NVIDIA card in it. And yes, why NVIDIA? Because I need a low-profile card, and it's the only thing I can get. This was planned for a long time, but with the whole GPU price shenanigans, I figured I think I want to get it now and not later, just in case. So the model is now running on the NVIDIA. OBS is running on the integrated graphics, and it all works. Also a good excuse to test multi-GPU when I actually get around to using this with Spout. So yeah, all seems to work fine. There's a bug in OBS or Qt or something. That means OBS doesn't run on the NVIDIA, but that's something I want to look into later. May or may not stream it. But anyway, it's a lot smoother now. It's not, borderline chugging along on the GPU that I can hold 60 FPS when I open certain OBS scenes and stuff like that, which is really nice. So yeah, that's the state of things. Let me say hi to people. Hello everyone, hello Wada, hello Master Papa, hello Didi. Lots of people that I haven't seen before. Hello Aki, hello Madison Webb, hello Minty Music, hello Christian Joaquin, hello Kotsa, hi, konnichiwa, hello Land Riders, hello the Code Guy, hello Mary, hello Gustavo, hello Minty Music, hello I think I raised the code guy. Hello, where am I? Hello, Wolf Boy. Hello, Nick Spears. Hello, Elsit. Hello, Nago. Hello, Kahana. Hello, Rai. Hello. And apparently, Cyan just arrived here.
Hello.
Grabbing something?
Huh?
Are you grabbing something?
Yeah, I wanna draw.
Okay, so you're just gonna draw. What are you gonna draw?
Do you have water?
I don't, and I could use some water though. I have some.
I can help you.
I have some tea, which is my plan for today.
Okay. Enjoy your tea.
How
long do you plan to stream?
I don't know, but if you need me, you can call me. So.
Okay. Love you.
Love you. Okay. So, yeah, that's the plan. By the way, Mary, did you get the thing to work? That she asked me about some Vulkan DMA buff import stuff, and I'm like, I did that in the last stream. Did you get that to work? By the way, I'm kind of curious. Yeah, that's the plan. So first thing, oh, and by the way, there's a side quest, which is why does Cyan's computer keep coming out of sleep? I've been fighting, like last night it was sleeping every 30 minutes and immediately waking up again. I have no idea why. I think I've narrowed it down to some USB devices, but I'm really confused. So if it doesn't, yeah.
My computer doesn't sleep?
It sleeps and then immediately wakes up. Now it's asleep. And I'm like, I'm not sure if it's the Stream Deck or the video capture card. It's something with USB. So I've been trying to narrow it down. You okay?
I ordered dim sum.
Oh, yeah.
In 30 minutes-ish. I'll bring it to you.
I just ate, so I'm pretty full. So I'll do it later. Okay. Yeah. Mary got it to work. It's under spec. Yeah, there's a lot of weirdness. Let me check the chats. So are we closer to Spout working? I mean, if I don't run out of time today, I think it's gonna work today. I could make it work today without the synchronization, but I don't want to cheat. I want to actually get this done right. Let's see. Will that have an impact on your development of this project? Not sure what that was a response to. Oh, always important to have extra info for all drivers in Mesa. User data. Wait, user data is a thing? I didn't even know the buff FD user data is a thing. Okay. Yeah. You think this will useful something this year? Oh yeah. This is gonna be done in a couple streams, max. At least to a testable level. So I think I mentioned the GPU. Like I'm going to be testing multi-GPU eventually. And the NVIDIA that I got means I can actually run this multi-GPU on my regular stream setup, so that's a good excuse to test that. Allocate memory arguments. Okay, I don't know enough about Vulkan to understand what's going on, so I'm just gonna shut up now. Sorry. Alright, so I think we can get started. And I just rebooted the dev machine too, so... Alright, so first things first, synchronization. So I wrote the Vulkan code, which is, if I can find this, the funnel source vulkan.c. Let me zoom in. And so this is doing buffer import. It's not that bad. The problem with this is that there is no synchronization. So, some of you may have heard about implicit sync and explicit sync. Synchronization is what you need to make sure that when the GPU can be parallel. The GPU can run multiple things at once, or you can have multiple GPUs. Synchronization is what you use to make sure that you don't start reading, a buffer on a GPU while it's being written to, because that would be a bad thing. It's a little more complicated than that, but that's basically it. So, oh, by the way, I am using NVIDIA with the open source driver, so it does not require explicit sync. That's only a problem with the NVIDIA proprietary driver. However, the thing is, Vulkan is always explicit sync. Vulkan is only explicit sync. There is no implicit sync in Vulkan whatsoever. Whether we like it or not, we're going to have to support explicit sync in the Vulkan implementation for libfunnel. And right now, there's no synchronization at all, which is a really bad idea. So, we need to make that work. And so implicit sync means that you don't actually synchronize anything. The driver just kind of does it magically for you. And synchronization is kind of attached to the texture buffer, whatever you want to call it. And it just kind of travels with it. And, when you read from a buffer, there is behind the scenes magically some synchronization that happens. And you don't need to worry about it. This was, in the past, done strictly in the kernel. It was kernel magic. These days, the Asahi driver, for example, which I contributed to, does not support implicit sync in the kernel. Instead, implicit sync is supported entirely by the user space driver. So there is some magic that you can use to convert explicit sync to implicit sync, and we're going to need that. So it uses that to support implicit sync entirely in Mesa. Without any kernel support at all. I mean, the kernel supports implicit sync in general, but the kernel driver does not. So, Vulkan is only explicit sync. However, the PipeWire stuff that we are doing can be implicit sync or explicit sync. And actually, it's easier to do implicit sync because, PipeWire is complicated and explicit sync complicates it even more. And there's even recent-ish bug fixes related to that going on behind the scenes. So, the OpenGL support we have doesn't have any sync. It's only implicit sync. This is all supposed to be synchronized properly in OpenGL. However, in Vulkan, it's not. So, we need to support explicit sync. And the thing is, if Vulkan doesn't support implicit sync, how does Vulkan work with, say, this PipeWire stuff when you don't have implicit sync enabled? Sorry, explicit. And the way you do that is the same way the driver makes implicit sync work with an explicit sync driver, which is by using some magic kernel functions that can convert explicit sync to implicit sync and vice versa. Why am I talking about all this? Because we're going to do the same thing. So we have Vulkan on one hand. We have this Vulkan.c here. And then we have this funnel.c that does not support explicit sync at all. So Vulkan doesn't have any sync right now. We need to add it. But we're going to not use explicit sync in PipeWire initially. We want to support implicit sync. No, explicit sync. But Vulkan doesn't do implicit sync. So we have to use some magic to convert explicit sync to implicit sync. And that is very useful because it means the user doesn't have to worry about any of this. If you write the Vulkan code with explicit sync, it will work with apps that only use implicit sync. So that means that then I can add explicit sync support to the PipeWire stuff. And then it's basically just removing the conversion code and adding the explicit sync support to PipeWire, to the PipeWire code. So yes, this gets a little bit complicated. I probably lost you by this point. So this is going to make a little bit more sense when I talk about the API. We need an API for this. So we have funnel stream set mode. It just sets the queuing mode. And we're going to have to add a function that sets the sync mode. Stream set sync. Synchronization mode for the stream. Mono sync. And what are the sync modes? You're thinking explicit and implicit sync. Actually, we are going to have 4 sync modes. And I promise this is going to make a little more sense once I write it out. So this is called synchronization mode for frame transfer. Actually, I'm going to call this for frame pacing, to make it clear that async and sync here in funnel is talking about the timing of the frames, whether it's asynchronous or synchronous between different apps. Now we're talking about GPU synchronization. So we're going to call this buffer synchronization mode for the just got it for frames. And our modes are going to be as follows. Funnel sync. And this is a little, I guess it should be probably funnel mode async or something like that, but the names are a little weird. Implicit. So this is implicit sync only. If you use this mode, that means that the PipeWire stream will only support implicit sync, and that you are not using any API for explicit sync. Then we have funnel sync explicit. Think about this. So remember, we have 4 modes, and I'm second guessing myself as to what I'm going to do. Sync explicit only. That means that we are going to require explicit sync on the PipeWire side. And if it is, if the other side has to support explicit sync, and we are not going to support implicit sync at all. Funnel sync both means that we support both implicit and explicit sync. And the user has to support both in their API. So this makes sense for OpenGL, where you can have both. And then whether implicit sync or explicit sync gets used depends on what the other side, what the receiver side supports. If it supports both, you get explicit. If it supports only implicit, you get implicit. But there's going to be an extra mode. Funnel sync, and I don't know what to call this. Maybe it should be called explicit. In this mode, the user of the API is using explicit sync always. However, the funnel will convert to implicit sync when required. So how do we explain these? Actually, let's call this actually call something like explicit explicit hybrid or something like that. Explicit sync either, let's call it like that. So let's say use explicit buffer sync with automatic conversion to implicit sync. Okay, so like that. And then we have explicit only. Support both explicit and implicit sync. for each DQ'd funnel buffer, and use explicit sync if the buffer has sync enabled. And we're going to have some APIs for that. Okay, good. So these are the 4 modes. All right. So, the next thing we need is funnel buffer has sync. And this returns a bool. Whether a buffer has check whether the buffer requires explicit synchronization, and then we need some APIs for synchronization. So the way we do that, and we need to think about the layering here, right? Because I'm a little bothered by this funnel sync name. Maybe it should be something like funnel. It should be synchronous. Because instead of synchronization, it's synchronous, right? And so that makes it a little more obvious. Otherwise, it's confusing with the. It's a little confusing with the other sync names. Let's get funnel sync. Some stuff in here. Let's just open the README and test VK and test EGL. So all that funnel synchronous. And put this in the README. Okay. Okay, so that's that. So now the API for this is the basic GBM API. Sorry, the GBM API will be here. So for explicit sync in GBM, what we need is basically to use sync objects. So let me look up at the PipeWire sync object. Buff. The way this works, because the way explicit sync works is that you have things called sync objects that carry the synchronization separately. And actually, the way PipeWire works is using only timeline synchronization. So it's supposed to use timeline sync objects. And so the way this works is that there's the sync timeline metadata, and this has the flags padding acquire point and release point. I think the way this works is that the buffers, the sync objects are persistent for the yeah, you can get the handles, right, in GBM. And since we are using GBM, we can convert the handles. And there's some extra weirdness with okay, let me look for something else, because there is a whole there's a whole issue in the GitLab PipeWire about something that was fixed in explicit sync because it was kind of broken. So let me see if I can pull up that issue, because there was some real subtle stuff that was fixed there. Search for all explicit. And I think the documentation has not been, yeah, this one. The docs have not been updated. So the problem was that when you drop a buffer, then the synchronization is never used. And if it's never used, then you can end up with a buffer that is stuck forever because nobody used it. So nobody actually triggered the sync points. One thing that I don't understand is why they had to do all this. Oh, wait, it's because they're using timeline sync objects. That makes sense. Because I was thinking that one way you could do this is avoid this whole mess is by pre-signaling the sync object. So the synchronization is like already set, and then when you send the buffer, it would be changed to one that is unset. But actually, I think with a timeline sync object, you can't actually do that. So that makes sense. But, so there's this whole thing with the timeline release, and it has a flag that has to be in the meta features. And then the idea is that so there's some examples and some commits here. Some process is supposed to pick up the acquire point, and if it has sync time release, unscheduled release. So you're supposed to check that flag and clear it, and this is all kind of confusing because it's not clear if it's backwards compatible. And I think OBS doesn't even support this yet. So we're gonna have to put this into our PipeWire code. Yeah, this all gets really subtle with the PipeWire side, which is why I don't actually want to support this in PipeWire yet. But what I really need is just the sync timeline points and the handles. So, one interesting thing is that Vulkan does not support importing timeline sync objects. It only supports importing binary sync objects. Because of course, even though Vulkan has timeline semaphores, and they are implemented with timeline sync objects, it doesn't actually support importing timeline sync objects. Not officially, anyway. There's an open issue for this. And it's not you can kind of do it, but it's not supported. So there's an import semaphore FD. And the way this actually is supposed to work is that there's a sync FD. So it only supports importing sync FDs, which are not sync objects. They are sync files. So this is all kind of a mess. Okay. So sync file or Android fence object. Yeah. So I think at the GBM interface, what we really want is to just export the sync handles, because there are non-DRM IO control. I need to remember these things are. Yeah. So this blog post is about this whole thing. Where's the actual thing? Maybe I should just read some of the code I wrote, because I actually wrote a bunch of this code. Why is that in like Chinese? That's weird. Oh, look. Look who's at the top. Hey Mary, you're at the top of the commit. At the top of main. Okay, so I actually wrote some of this code here and see if I can remember it. I think it's an Ajax device. Yeah, so you can export the DRM sync object, export sync file, and that is what we're gonna need for getting the sync file that we need to grab for Vulkan, but that's for binary sync objects. And sync objects are timeline in PipeWire, so actually we need something else. Where's the point stuff here? Is it here? Is this just old? It might be old. Just get lab, pre-desktop. Where's the DRM? So many clones. Where's the official one? Where's the official one? Is it even here, or is it DRM? Does it live somewhere else? Actually, where does the DRM live? Android, whatever. Come on, where's the official repo? It is okay. It's Mesa DRM.git. Hello, happy New Year. Okay, and this is where? Should be here. Okay, so you can do sync object timeline signal, timeline wait. Query to transfer. So I think we're gonna need a transfer because we can. There's an event FD stuff in here. Import sync file, FD to handle, handle to FD, destroy, create. Wait, reset, signal, timeline signal, timeline wait. Yeah, so we're gonna need the transfer function, I think, to transfer it into a timeline sync object. Where's the STI controls? Here it is. This is important. Importing a sync object creates a new handle, very important instead of deduplicating. Okay, so that's useful. So the sync object transfer stuff uses handle. So I think what we want to do for our API is have the core just import into handles. And then you get the handle and the point. And there's the sync file stuff. Where is this struct defined? Oh, it does have a foil. Wait, handle to FDI control point. Where's the point? The point? There is... Okay, oh, there is a... Okay, hold on. How new is this? We might be able to avoid some nonsense. If we use some features that are newer. We might be able to avoid the timeline stuff. Sync file 9 years ago, and then timeline 10 months ago. Oh, fun. So this is actually really recent. Do I want to rely on this? I guess we could check whether this is supported. Yeah, so we're gonna need this for the Vulkan stuff. Either way, all of this is using all of this is using handles. So we want a handle. I think we can support both. How is this? Here's the patchwork link. How do we check if this is supported? Drivers and object timeline. I mean, you better support timelines and objects because PipeWire depends on that. Wait, hold on. Is this... Why is this 1-to-1? Where's the import? To the export sync file. FT to handle import sync file. So both of them have it. But there's no support check. So I guess we just try, and if we get an E and Val, then it's not supported. I think that's the only reasonable thing to do. Anyway, so we need to get the sync. Final buffer, get... in sync. Get the sync object and point for and before I do that, actually, the weight also takes handles, right? Yes, okay. There's a timeline weight with handles, points, yeah, okay. Must wait on the sync object before accessing the buffer. And Cyan's computer just turned on. So now I am really annoyed. I'm going to try to unplug some more USB devices and see if it works. 1 second. So, I just unplugged the Stream Deck. Let's see if that helps any. Yeah, so you must wait on this sync object on this timeline before accessing the buffer. Buffer get in sync, buffer, and handles are uint32t handle. And points are 64 bits. Releasing the buffer. Get out sync. Signal. This timeline sync object after access to the buffer is complete. So handle output DRM sync object handle. Point to in sync object. Out. Check out the in and out. It's called acquire release. It's called acquire because PipeWire uses that naming. Release. And that wasn't formatted. So I think that's pretty much the only API we need on the general side of things. And then we'll have to add a Vulkan thing to that. So first let's add the API for not the API, the internals for sync. So in buffer, let's add a little struct here, struct sync point handle acquire release, and then we need a bool backend sync and bool frontend. Actually, no. Sorry. These are for buffers, not that. So the buffers. Backend sync, frontend sync. So backend sync is whether PipeWire has explicit sync. Frontend sync is whether the user is seeing sync because we do the conversion, right? And then we need to have the mode configured in the string config here. Final sync. Okay. So in stream config, first we need to set a default. And by default, we're going to just have implicit because that's sort of the, you know, legacy, whatever. Sorry, sync. Actually, we can just call the function stream set sync stream funnel sync implicit. All right, so first let's implement this function that sets the sync. Sync stream sync 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 sync. And we need a little layering violation here because case funnel sync implicit case funnel sync either if stream API equals API Vulkan, and that is not supported. And follow through. All right, so next up, the funnel, the thing with get user data. Right after that, we had the API that has sync. So that is very simple. We are just going to return buff front-end sync. Now for the actual buffer allocation. So also, we're not actually going to support explicit sync in the backend yet. I'm going to add a little explicit only this is just for now, because I'm not going to implement explicit sync on the PipeWire side just yet until we get it working with implicit sync first. So now, when we actually get the buffers, on add buffer, backend sync equals false, because we don't have that yet. And then we need to support the conversion stuff. So if stream cur.sync equals config.sync equals funnel sync explicit hybrid, So if we don't have back in sync and we have hybrid mode, then we need to allocate some sync objects. Which means we actually need to set, make sure we have things here. Okay, we have the acquire and release points. So by default, front end sync equals back end sync. However, in this special case, we did true. So let's implement this first. The way we do explicit sync and implicit sync conversion is by first, we need to allocate some sync objects. So we need a sync object create. And we need a DRM FD in here, stream, GPM. GBM device get FD is what we want. Because we're using libgbm, so that manages the FD for us. And then we need to use this DRM stuff. So we're gonna have to grab grab some include files in here. Which probably means I need to depend on that package. It's just there. What package is this? libdrm devil. Do I want to depend on this or because we don't even have support for the. Do we have the flags? No, we don't have the point stuff in the. This is all really new. Sync object handle, and include UAPI, all that stuff. So that is in libdrm, and I bet it doesn't have this update yet. Let's see. Oh, it does have the point. Okay. So that is actually updated in libdrm on my system. So that probably means we can include it. Yeah, it is in there. Okay, good. So you can probably have like an if-def based on that. But that's for the Vulkan driver anyway. So where's libdrm? I had libdrm somewhere. I guess this wasn't added to the API. It probably was just added in here. Yeah, sync object timeline. No, sorry. Yeah, this was done. It's not used. Okay, so this isn't actually supported in the DRM yet. But it has the header files. Either way, I want to just create a sync object for now. So let's do the create. So the way we create is DRM sync object create. FD and flags. What are the flags? I mean the timeline flag. And we should probably check whether this is supported before even enabling explicit sync. Is there a function for checking for sync object support? Timeline sync objects. It doesn't have the timeline. Do we have a get? Do we have a... There's DRM get cap, but I'm not sure if that's what I want. It might be what I want. Where's that used? Is that okay? So we probably want to check that first when we initialize the device. So in init GBM, let's do a check and put this in a bool somewhere. So we need to double check that it's supported on timeline sync. And we can check this in the mode too, because if we don't have timeline sync objects, we don't do explicit sync. So in set sync, so if we don't have sync objects, we have to use sync explicit hybrid, explicit only. can actually do it like this then. Break. And that makes this whole logic a little more reasonable. So it would be nice to test if we support the whole import stuff. Is there some way we can? There's no handle to FD flex timeline. How do we want to do that? I think we can do a test for that in the init function. FD to handle flags. Let me check what the kernel code is doing for this one. The kernel code for... Where are we? For example, if I try to export a sync file with timeline, it grabs a point. It would return E and val if this is not supported. Before that change. And that is only supported for exporting sync files. And then export sync file, what that's actually doing is find fence with point. So 0 is what we already had. And then find fence is going to look for... Actually, you know what? Hold on. It does a sync object find on the file private and handle. If it can't find the handle, then it returns enoent. So I think we can probably just use an invalid handle. And if we get enoent, then that's fine. And And then it does a fence get. If it doesn't have a fence, it returns E and val. All this go-to stuff is so weird. Anyway, what I want to know is, yeah, if this returns, you know, and if the sync object doesn't exist, which is probably the easiest thing. So, in sync object find, this is IDR. IDR find. Surprised this is not using X-array. Oh, apparently it's supposed to be X-ray now. Okay. Either way, I don't know if 0 is guaranteed to not... Let's see, how is this initialized for sync objects? Yeah, it starts at 1, right? So I think we can just use 0. Yeah. So 0 should always be an invalid handle. So I think we can just use that that API to check. So let's see if that works. So we do this get cap. If we have timeline sync, then we need to call that API. And I don't even need to use the sync file thing. I can just say everything is 0, just pass in the timeline flag. Hello. I'm not hungry yet, so I'll eat a little later. Okay. No, maybe back there? Oh, interesting. Doesn't return E and val if it can't find it. So that's kind of interesting. I guess ideally I should just export, like create a new sync file. That is a timeline sync file. Let me just cheat a little bit. See if I can do that. And just to make sure this compiles with older versions, let's do this. Handle equals 0. Added. Flags equals handle to a D. Flags. Let's export a sync file. In timeline. That's it. So how do I call an ioctl? Do I have an ioctl thing here in the API? Not sure. Yeah, there's a DRM ioctl. That's what I want. Request and arg. Handle to FD. Args. And let's do a print here. By the way, I have to convert all these prints to like a proper log thing later, but for now I'm just using this. So, so that should be enough to check if this all works. And that means I'm gonna need libdrm in the Mason stuff. And Vulkan is also going to depend on that because shenanigans. Why does this depend on EGL? I forget. Does that even make sense? Turn this off for now. Okay, it does compile. So test EGL, did this work? Ah, it says import export equals 0. Is this kernel old? Probably 6.16.12. that was released in July, which probably means it was RC0 was probably tagged a few months earlier. When did this get merged? Good question. File. I think I might need to update my kernel. .616. Actually, it is there. It should be in 616. That's actually literally the last change that made it into this particular release. So this didn't work. -1? What's -1? That's E and Val. No, -1 is what? I think -1 is... Wait, oh, sorry. I error number. -1... Yes, this better always fail, because otherwise it doesn't make any sense. Okay, so error number is number 2, which is enoint. Yeah, so it does work. It does work. Cool, this hack works. If I pass it like a bad flag, then you get... Oh, no, wait, what? Sorry, like something else. Yeah, then you get E and Val. So this hack does work. Cool. So now that we know that this actually works, let's go back to the DRM sync object create. So we create a sync object. And the flags for this are what? Flags, sync object. What are the flags for this? Wait, create signal? No, how do I create a timeline? Or all sync objects timeline anyway. I think all sync objects are probably timeline anyway. Yeah, I think it's just because of the way the DMA fences work. All sync objects are implicitly timeline. Yeah, I think you pretty much just assume that these are always timeline sync objects. So I guess no flags then. And then, actually, I'm not even sure if I'm supposed to create. Yeah, I'm supposed to create a sync object, and then, what are the things here? Handle, I think we can just assert on that because we can't actually do anything on buffer allocs when it doesn't work. So, just put it directly in the handle. I don't know if we're supposed to start in 0.0, 0.1, but we're gonna try with 0 and see what happens. So now we need the magic DMA buff stuff for importing and exporting, and those are definitely used in the Mesa stuff. Yeah, DMA buff IO control import sync file. These things. And those are in Linux DMA buff. So now we need those. I guess we need kernel headers. Is that a thing? What's the right dependency on that? The package config. How do I specify a dependency on Linux headers? This is gonna work, but we're gonna try. No, that doesn't work. Mason, kernel, headers. Come on. Someone must have done this before. How do I check for that? Oh, and Science PC is on again, so I'm gonna unplug some other stuff and try again. Like I said, now I've turned off like everything except the mouse and another weird USB cable that shouldn't be doing anything. I think it just turned on again. Okay, now I unplugged a weird cable that I am suspicious of. That is connected to a KVM that doesn't have that input selected, but who knows? So let's see if it stays off now. Okay. Yeah, I guess I need to use the has header. Okay, Mason has header. How do I do that? Mason get compiler. And then how do I error out? Probably just error. How does it work? Is it Python or? I don't know how if works. Okay, something like that. No? It's indif. Okay, so. Double quotes are not supported. Interesting. That is a choice. get compiler needs a argument of language, I guess, is C. Okay, that works. And then I guess we don't really specify a dependency. We just go with that. Yeah, that works. Okay. So DMA buff. And then back to that function. Does all this stuff. So this is how we call that. Import sync file. And where's the export sync file? Okay, here we go. Export sync file. We don't have anything for sync objects. Yeah, we have to go through sync files. So we have the buffers. Now for the actual import export. What we do is when we dequeue, we need to grab the buffer from the DMA buff. So same logic on the allocate buffer stuff here. Oh, and we also need to delete the sync object. So if in the release function, we need to make sure we destroy those. In free, bo destroy. If it's hybrid, then we do how do I destroy? Sync object. Yeah, just destroy. I guess I don't really need to even assert here, because if it fails, it fails. Just kind of... I guess might as well assert, yeah. you want to set front and sync equals true here. So actually, if buffer front and sync. So if we don't have back in sync, we do the magic counting. Otherwise, it would be to do here. So when we get a buffer, what we need to do is grab the sync file. And I guess in this case it would be sync write, because we are not reading. Actually, we are. I think for writing, actually, you want to use RW, and then. Yeah, I think you want to use RW for writing, and then for reading, you want to use read. I'm not even sure what's going on with those, but and then for import, you use write. Yeah, because you want to sync against readers and writers on export. And I think we always have to have an FD, so that should be fine. Oh, sorry. We call it on the FD, and we get an FD out of here. So it's export sync file. Arcs. Let's call it arcs. And then we import it into the timeline. And this is where we have to use those APIs. So I think I need a funnel internal. Like we need. Wait, no, we are using timeline sync objects into export and import. I'm importing into the timeline sync object a sync file. So that's the same thing as on return. So I can write some generic functions for this. I guess I could just like, yeah, I guess I could expose them. So this helper to import a sync file into a timeline sync object. Because this code is going to be different depending on whether the kernel supports that magic stuff. Export a sync file from a timeline sync object. So then let me just implement these in here. So if we have timeline import export, then we do just use that, which means copy and paste this, export sync file. So for export, we would do handle is handle, export sync file timeline, the point equals point. Here my control, stream GBM, sync object, handle to FD arcs, if ret is less than 0, return minus error number. Otherwise, you have to do some dance. We have to import this into a different sync object and then transfer. Which I guess means we might as well create a temporary sync object to just use for everything and not have to recreate it. Oh, this can just be on the stream. Sorry, not even this can just be global. It can be global because we do lock the... Do we lock on DQ? Yeah, we take the loop. And then, yeah, we do take the lock on DQ. So that means we can actually just use a single global sync object for this. Might as well just throw this in here. And then in destroy, we have to clear this out. So, and GBM is already destroyed here, so we have to do that here. So the magic here would be we do that. Otherwise, we have to do it into a dummy sync object without that. So actually, we can reuse this code. Put this in here. And we should have the if-def in there. Actually, you can do that like this. If we have timeline import export, args point equals point. And this isn't invalid. Handle to FD next timeline. Assert on that. In this case, we just the return here is the same. This is for export sync file, but we need a transfer in here otherwise. So the arguments here are FD, comma, destination handle. FT, destination point, source handle point, flags. Okay. Destination handle 2, point, source handle is handle, source point is point, and flags, I don't know what flags this takes. This takes what flags? Where am I? Sync objects. This is an old version. Where's Mesa? I don't know if there are any flags for this actually. I think there aren't any. Yeah, something like that. So if we have to export a sync file and we don't have and we don't have the feature, then we have to grab the point, transfer it to the dummy sync object at position 0, and then we do the handle to FD. And then the other function is basically going to be the other way around. We have to... Let me just copy all this around. Import sync file. If we have that, we just... import straight into the handle. Otherwise, we just import into the dummy sync object. And then, again, if we have if we don't have it, we don't actually need to check anything then. Then we do the sync object transfer the other way around. From the dummy sync object into the destination. Let me reread this to make sure it makes sense. So if we have the flag and we support that, then pass it in, set the handle straight into the handle on the point, otherwise into the dummy sync object. And then if we don't have the feature, we need to grab it from the dummy sync object and move it to the handle and point. Yeah, I think that makes sense. Then the other thing to note is that I don't know if this consumes the FD. It probably doesn't. So we just need to make sure that is documented. Obviously, handle to FD will return a new FD. Let's just set it to -1. And do a sanity check there. Let's do some sanity checks here. Okay. We're getting something. I think this should work and be backwards compatible. So we can test later if this works by forcing this to not exist. Or just can get on def of this even. So now we have these helper functions that we're going to use because we need to import a sync file in the buffer in the stream DQ. So now in here, handle acquire point. And that should always succeed. Did I not import final GBM in here? Oh, I didn't. I need to do that. So this is the implicit sync to explicit sync conversion magic. And then we want to increase the point because we're grabbing that more than once. And then on the other way around, we are doing an enqueue. This should just be done here in the main enqueue function because it we basically always want to do it I mean, I guess it could be done. It could be deferred if we don't actually send the buffers to PipeWire, but I think it doesn't really hurt to just do it every time. It'll just be a little more noisy when in async mode. It's a little safer to do here than to do later. So, so we grab the do a sync right. Export sync file. And we grab the release point. So the only tricky thing here is that because this is a sync file, it is possible that this is not yet signaled the way sync objects work. Sorry, sync files always have offense. Sync objects might not. So for a sync object, we would possibly want to actually oh yeah, actually, I'm gonna do one more thing here. Just as a sort of sanity check for it's a sanity check for people writing bad code. If it has front-end sync, if you try to enqueue a buffer and you haven't checked the sync, that means you haven't done it right. So, and I guess in this case, do I want to return error? Yeah, I guess we can just assert in this case, because this means that this is a programming mistake. You should never do this. Do I want to assert? I guess we're not really asserting anywhere else, so so then in DQ here we want to at least do that. Okay, so we export the sync file from the release handle and point to FD. And that should never fail unless the user has... The user shouldn't really... Yeah, actually, what happens if that does not exist yet? That's an important thing to check. What does the kernel do in a fence if it doesn't exist yet? It does a find fence. Find sequence number. How does that work? I remember this being very confusing in the kernel. EN valve defense is not a chain node, or the synchronous number has not yet advanced far enough. So in that case, we get an EN val. From the export. And if we get an EN val, that means we need to either wait for submit or... but that uses 0, so that's going to return an EN val. This can fail if the user did something wrong. So the only thing I don't know is whether here is whether, depending on what API you use, in principle, you could set things up so that the sync is submitted later, but I don't think that actually makes any sense here. So we're just going to return an error in this case. Oh, and also in acquire here, we want to also increment the release point, I guess. I guess no, that would only be done in queue. I guess just return error number on that. So now we have a file descriptor, hopefully. And then we want to do import sync file args. And this one is, where is my header file? It's in DMA buff. Here. Yeah, it's just flags and FD. And that should never fail. Okay, so this is the explicit sync to implicit sync conversion magic. And then we need to support this in PipeWire. Not in PipeWire, sorry, in Vulkan. Now you're making me hungry. The sign is you're eating, and I'm like, what? Okay. So first let's get the Vulkan, so I'm we initialize Vulkan here, we need to call... set sync stream. And default the hybrid for Vulkan. And now if I run the Vulkan demo, it should just outright fail. Or not. Alright, we're not enqueuing anything, so we don't get anything. I need to, like, run OBS and stuff. And that needs to be run in my, in all that. Okay, so now in this whole mess here, plug this into OBS. Actually, it's activate. Okay, so that failed where? 126. Wait, we can't create a sync object? What? How? You know, TTY, what? Is this the wrong... But we are... This did work in at the end here. Oh, and I probably need to close the sync files. I forgot about that. In DQ, I need to close the files. That doesn't make any sense. 126. Wait, how are we creating a sync object on the 5 and then 47? Wait, what? Okay, that's mostly the driver doing all that stuff. Where did this 47 come from? It is 47. How? What? Oh, because this is in the dummy case. Okay, so in the dummy case, wait, what? Yeah, so it does work here. Oh, is it because I didn't initialize something? No, wait. There's nothing to initialize. Oh, is it because handles are not 0? No, that doesn't make sense. Oh, there's a close 47 here. Wait, why is there a close 47? That does not... Oh, wait, hold on. What? Wait, what? Why is there a close? Whoa, hold on, what? Is it because Vulkan is initializing... Oh, we're probably passing the file descriptor? No. Oh, we close it here. Okay, we close it because... Ah, right, okay. So that actually needs to stay. How did this ever work? Because then we allocate DMA buffers on that. Wait, what? That's broken. Yeah, we always close it, so this needs to... Right. So GBM create device does not copy the file descriptor. Okay, yeah. How does co-exit? There's a way of duplicating file descriptors. That's the right way to do it. Yeah, this thing. So then the DBM destroy device stuff, does that close it? Device destroy, ref count destroy. I don't know if that actually closes it. I guess look for Mesa. Device create FD. Okay, that does not. Yeah, it does that. So what about destroy? Destroy does not free the file descriptor. So I guess we have to do that. And sync destroy if we have GBM. That still doesn't work. Why? And now it's failing in handle to FD. That sounds wrong. Because that's FD to handle. Okay, that went a little further. Yeah, so now it's complaining about the sync. That's what I want. So that means my little dance with the conversion worked, and then I can undo this this little hack here. Okay, cool. probably should just do this separately in Git. That should be a fix-up for something else, but whatever. I guess my code formatting changed at some point. Whatever, just give me it. Okay, cool. Now. We need to plug this into Vulkan. Okay, I'm gonna take a very quick break. Copy her back. Okay, I just realized this doesn't make any sense because Vulkan is using sync files. We're using sync files with DMA buff. So in the hybrid case, we're going through a sync file for no reason. And I think what I really want is to split this out so we have support for both sync objects and sync files. And that way you can just use whichever one makes more sense. Get acquire sync file. And get release sync file. Sync file for releasing the buffer. Oh wait, no. For releasing the buffer, it wouldn't be a sync object. It would be set release sync file. The sync file must be signaled when access to the buffer is complete. And that means that then, in funnel, what we actually want to do is move this code to those functions. Instead of in the buffer functions, we just move the, and these are in GBM, which is also nice because it means we can actually move this to a different file. It's too much stuff in one file. When did I close this? I didn't close this. Oh, I didn't implement these yet. I have to implement those. Okay. And that should document that this needs to be closed. Got it owned by the caller. And so then I can move that code. And then DQ here. I can move all this to the back. So we just set query to false for new buffers. And then we do this dance when we actually call the sync object. So if we get acquire sync object, then if we don't have back in sync, then we want to grab the acquire handle, grab the acquire point, and if we don't have back in sync, actually if front end sync, inval, if we don't have back in sync, we do the dance here, and and actually I can just get the sync file in this case. But I guess it's a little weirdly recursive if I do that, so let's do it separately. So then get release sync point would be the converse of that. So return 0 here. Move this out. Eats. Then we export the sync file. This is the buff stream. Oh, wait, no. In this case, we just grab... You always grab the release sync object. We have to do that on... This has to be done on submit. Sorry. So this actually has to happen. On submit, we would... Yeah. So we set query to true. And if we don't have back in sync, we export the sync file, or we already yes, I need another flag for that. So if we have back in sync, if we don't have back in sync and we haven't set the sync file yet, then it does all this stuff. Release sync file set, release sync object. We can do another check here. If release sync file set, printf here, if we don't have the sync file set and buff release queried, so then in this case, if we set the release sync file and we don't have backend sync, then we just do the import. Otherwise, we would have to transfer it to the So if we don't have backend sync, we just import it into the DMA buff. Otherwise, we have to do the opposite and import it into the sync file. And in that case, return that. And in get acquire sync file, do the same thing as this. Where if we don't have back in sync, we just grab the FD using this. Otherwise, we have to get it. Export sync file. And then we don't really need to make those functions public anymore. Yeah, then we don't need to make these helpers public anymore. Because this supports all the APIs. So just make these static and put the prototypes at the top. I probably need to open the... And I guess it's you need to depend on that because we're just can do it unconditionally. So now set release sync file. These are all done. Get acquire a sync file. So it's stream handle point FD. Stream handle point and the FD just pass the parent FD. Yeah, that should work. Whoops. What went wrong here? Stream diagnostics. So now it's complaining about the sync. What we can do as a very quick test is we can go on Q and in Q we can just cheat a little. Get acquire sync file, buff. So this should effectively do what we've had before. Yeah, that works. And it goes into OBS, okay. So that means that at least none of the function calls are failing. So our sync file stuff works, but we're still not synchronizing because we're just getting the same sync file. So now that means the Vulkan code can just use that. And the other question is, how does it work for EGL? Let me see what OBS was doing for the PipeWire code. Acquire sync object FT. Create from sync object timeline point. What does that do? It does FT to handle, does a time, it does a wait until available. Which I guess we should do that on the incoming when we do a get sync file. Then it does a temporary handle, transfer state, export sync. Okay, it's doing that whole dance. And then uses EGL. So it does EGL create sync. Okay, this is what we need, right? So for EGL, this is how we would support explicit sync. So we might as well add this to the EGL API now. EGL get acquire EGL sync. And then for release, it's the other way around. EGL.native fans have the Android, yeah. Release EGL sync. So then for EGL, yeah, I guess this is gonna be easier to test on EGL, so let's try that. Stream, funnel, sync. Explicit hybrid. So by default, we'll use sync either because that's easier for EGL. That's the most flexible thing. And then just do this. Sync, sync, implicit, explicit sync only, explicit sync hybrid. And just it's called hybrid, either sync. Hybrid, either. So if we have sync, Then go sync acquire. And we call that get acquire EGL sync. And the way that works with EGL is that whatever this is doing, it does a sync wait. It's an EGL comment. Just EGL wait sync, okay. Release EGL sync. And that would be EGL create sync. Let's just check the sync object. Does it need to be a sync native fence Android? I guess it needs to be a native fence Android. I guess we need to document that. So in EGL we do that. This calls the GL flush after that. I don't know if that actually makes any sense. I guess to be able to... I'm not sure actually, because that creates... I think you don't actually need to GL flush here. I think that should just do it by itself. Because EGL creates sync. It's just an insert defense into the command stream. So I don't think you need a GL flush in there. So then in the EGL part of the code, this is pretty simple. We basically just grab the sync file and do the import dance. So from PipeWire here, we can... It's basically just this one. Acquire sync file. And the display is in CTX. And we use constant over here. And actually, does EGL take ownership of that? Okay, so this takes ownership of the FT. So set release EGL sync. Set release sync file buff FD. Right. And then we close it. And then we need to grab this extension thing. So that needs to come in here. And the other thing is that I should, if we don't support this extension, we should probably disable explicit sync. Actually, disable explicit sync. Which I can just cheat. I probably need an extra. Yeah, I need an extra like API supports explicit versus implicit sync thing. And then I don't have to have this horrible hack here. So the way I would do that is explicit sync is if we have this API. And then in Vulkan, we do the same thing. False. True. I guess we can just do not supported there because yeah, so if the API doesn't support explicit sync and you pass either, you just always get implicit sync. So it is allowed. Sorry, I need some water. It is allowed to require to request either for EGL if it doesn't have the support, and then in that case, it would just always use implicit sync. But in that case, in that case, I need an extra check here for the mode. Sorry, instead sync. Actually, I think what I really want to call these is API requires explicit sync. So then Vulkan would have true and true. Yeah, that makes sense. And so then, as usual, this is more complicated than expected. I need to also initialize these in funnel GBM. API supports explicit sync. Depends on GBM timeline sync. And in that case, we don't even need to check that here. And then we just only set it to false. Only chorus to false if we don't have the right extension. And so then we can call that. Okay, so we have EGL, no buffers. Why no buffers? Okay, that does work. So if I request explicit sync, that's gonna so explicit sync only, that's gonna fail because we don't support that yet. Hybrid seems like it works. Implicit sync. Either sync. Yeah, that looks like it works. Let me just do some prints here to make sure it's actually working. it does work. It has sync. And then I want to destroy this sync as soon as I do that. Okay, cool. And then, let me check to see if I'm leaking any file descriptors. Looks like I'm not. That's good. I'm not. Excellent. Okay, so we can do some git commits here. First, not the EGL stuff. Let's commit these changes. Not to that. Actually, I probably want to do this. Set these like that first. So there's explicit sync for EGL, and now finally we have to add explicit sync for Vulkan. So right now Vulkan should complain. It doesn't complain. Why doesn't it complain? Did I forget to fix the... Did I forget to remove the hack? No? Wait, what? Oh, because it's not connected. Why is it not connected? Because OBS died? Or because I closed it? Okay, yeah. So it fails because of that. But EGL works. Yeah, so in explicit sync only, it's failing because of that test on 284. Wait, what? No, it should support it. Shouldn't be failing here. It should be failing later. Wait, hold on. What? So this sync works in high mode, but that's weird. Oh, either sync. Okay, so that has no sync. Because we don't have the backend support yet. But hybrid does have sync. So why is this failing in 284? That doesn't make sense. It shouldn't be failing in set sync. It should be failing later. It just shouldn't negotiate. Oh no, it's this one. Sorry, it's because I have this to do here. Never mind. Yeah, okay, that's fine. Oh, what was that? A lot of stuff. I think I'm not gonna get to Spout2 today. But at least let's get the Vulkan stuff done. Okay, so in Vulkan, this all works with semaphores. And I remember there was some, I think, what is it? GameScope is Vulkan. I think there was an example of explicit sync in here. Yeah, so this is actually GameScope doing some crazy stuff that doesn't make sense. But this is actually the kind of code we want. Oh, and there's one more thing we haven't done that I need to do. In funnel.c, when we do a sync file, get acquire sync file, I actually need to do a wait. And I need to wait for the sync object to be in queued. Otherwise, it would fail for some use cases. So for that, I need to go into... Where am I? PipeWire was, OBS was doing this somewhere. Yeah, sync object timeline wait is needed. Where is this? Ah, it needs to be right. It's because it's a number. Yeah, okay. So timeline wait. Handle acquire point. Want insect max. Wait available. That's what we want. And null. And I think this can actually wait if the other side did something wrong. So, just make sure everything still works. Yeah, looks like it works. Actually, no. This never gets hit because we are not using backend sync. So once we have backend sync, we'll have to see if this actually works. But for now, cool, that's that. And now, Vulkan. See, this is the same transfer dance we were doing with the temporary thing for when those new APIs are not supported. Same wait available business here. Yeah, so this is the actual important part. So I think we basically just create a VK semaphore for the acquire and release points, and we're gonna basically, the user has to signal one and wait on the other one. Wait semaphores. So then there is a little tricky thing here because we need to create a semaphore to be signaled by the command buffer, and then that semaphore needs to actually have its sync file transferred when we queue the buffer. Unless we want to just have the user create the semaphore and then pass it in. But that's a little bit of a confusing API because Vulkan doesn't actually, like, there's no way to guarantee that that is called after the command buffers are submitted, so we probably want to do it in here, which means we actually need a callback. And that can be an int because we check it first. And that means that we probably also need to have like a reused buffer or something like that. I guess might as well move this here. So the only thing is I don't know when the semaphores are allowed to be destroyed, and this can be a little bit weird. When is the semaphore allowed to be destroyed? Because there's this whole temporary and it's not a fence, it's a semaphore. Okay, applicant is going to run semaphore payload and don't exist in semaphore. Would either be temporary or permanent. If it's temporary, must restore the semaphore to its current state after submitting the next semaphore wait operation. Okay. Also, I think Cyan's computer did turn on again. So I don't even know what's going on anymore. I have no idea what is causing it to wake up. Wait, operations. All submitted batches that refer to semaphore must have completed execution. So that's annoying. Because I don't even know how to wait. So if I don't want to be recreating semaphores then, I guess, but if we're importing, it's the same story. This is really painful. I mean, I could use a timeline semaphore, but then I have to do the transfer stuff. And then I have to require Vulkan 1.2. Semaphore must not be associated with any queue command that has not yet completed execution on that queue. See, the thing is, then this requires essentially a fence on the previous user of the buffer. I can probably just cheat. Because the acquire has to be signaled before release. When the Vulkan thing, essentially when a buffer is reused, the previous write into the buffer must have completed. So I think I can probably just force a wait on the semaphore. And because I can't wait on semaphores in Vulkan, I can just cheat and use like a sync file. I don't know what the validation layer is going to think about this. It might be very unhappy at me, but we'll see what happens. So an alloc buffer does all this stuff. And basically just create semaphore. Yeah, so we just create semaphores, and then free buffer, we do a, how do a sync file wait? There has to be a way of doing sync file wait. think this is like a poll or something like that. I mean, I could just use sync object and wait on it, but sync file allo, create, fd get fence, get names events, merge, pull. Yeah, I think you just do a pull. Yeah, so we just wait sync file equal in. Yeah, it's just equal in. You can just select on that or pull NFTs, NFTs, right? No, just pull. Next, sync file. Yeah, and then we just do that. That's my little hack, and hopefully the Vulkan validation layer is not going to complain too much about this. About me cheating with this. Okay. So yeah, we can just use this to guarantee that we meet the Vulkan obligations. And so then, PK destroy semaphore. Device semaphore allocator. Okay. Wire. Release. And so then the API is basically going to be the same as EGL but with semaphores instead of syncs. And in this case, we use get instead of set. VK semaphore. And so then, in Vulkan.c, we first get the VK buffer. And we do what this really does is not just get the semaphore, it actually does the import dance. Actually, for release, it would just be the buffer. Release. Actually, we can just do the asserts in the buffer alloc. buff release. Key buff acquire. So then in the API here, we called it, let's call this NQ buffer. And an NQ buffer what we want to do is basically set the query flag on release if this was called. Let's just move this to the top so that the Vulkan calls can call this, set the query flags before, and then we would like unset them and hack a bit. So when we call the acquire call, we want to actually get the sync file here. So we don't need to call that. The same as EGL, we get the sync file like that. And then we need to import it into, so we need to first do the wait. For wait idle, VK buff. And get acquire sync file, we need to do the import, and there was some I do that. I don't know if it makes sense to use temporary or permanent. I guess it would make sense to just use permanent. don't know what the difference is. And I need to get the device. Where's VKS? Stream API CTX. And this should be checked here, actually. Device info. And so then I need the callback in queue buffer. So, and in queue buffer, and then we do this export stuff. Wait, what? This is doing creating a semaphore directly from Oh no, this is export semaphore create info. Oh, because I guess we need to do this to create right, so when we're going to export it, it needs to know about that. So we can do this. Info. Create acquire and create release. So acquire doesn't need any special flags, but release does need a export info because we're going to be exporting the release point. Okay, so that makes sense. Create acquire, create release. And then it's get semaphore FD, so this part. And don't need the weight on here, but what we need is the release semaphore. Failed to export sync file from semaphore. VKS device, and this is VK buff. Set release sync file to FD. And then there was a thing with the FD being -1 when it's already signaled, and I'm not sure if that makes any sense. There was something about -1, but I don't know if that's actually... I think we don't actually need to do that, hopefully. close it before checking anything. And just return red. Okay, this might actually work. So here is the Vulkan support. Oh, we don't need this one anymore. On and queue buffer. Oh, and we need to set. Sorry, I don't need to close it. I actually need to set. Yeah. Hold on. I'm waiting. Yeah. So on acquire, we always call wait idle. So this should already be. We better have acquire queried, which means it's idle. And then that means we can definitely import it. Actually, we don't even care about that, but we need to keep hold of the file descriptor. So there should be no async file. Oh, and I didn't print the hash sync. And now another one with the pointers. And somehow Cyan's computer is on again and I'm really getting upset now. Why? How? Hold on. Okay, now I haven't plugged like the whole USB hub, so if it turns on again, I don't know what's going on. Okay, so now it complains about explicit sync. And now I have to actually use the semaphores. Which we would do here. Honestly, the semaphores could just be done, I could just do both at the same time, because it doesn't really make a difference. Okay, we got a sick fault. Okay, what's is complaining about what? Does not support feature exportable bit. Do we need Vulkan 1.1 for this? I think I need this extension. Oops. Okay. Where am I? Vulkan. That's not supported? Is it an instance? Ah, okay, that's better. And now we're recrashing. We're crashing and a nub function pointer and get VK semaphores. Why are we doing that? It's not this. It should be complaining about no extension if this is not set. So that is set. So why is this exec faulting? I guess we need debug info D. That did not help. Well, that's painful. And why is that null? Import semaphore FDKHR. Probably because I'm missing an extension. Okay, there we go. So now it failed on poll. And we have a lot of validation errors. Whoa, what happened here? Oh, it needs multiple... Okay, yeah, it needs the... Okay, that fixed the validation, but now we're failing on the poll. Oh, sorry. Poll. It needs to be equals 1. Because there's 1. Ah, that works. That works. Woo! Okay, now it's going really fast. Because we're not synchronized, I think. Wait, we should be synchronized with the screen at least. What happened here? So sync is synchronized with... Oh yeah, because in the presentation we weren't doing that, I guess. I think. No, wait, async does that. Hold on, what? Isn't the default async? Oh, it's because I said it's a mailbox by default. That does not make sense. If we're defaulting to async, we should be using FIFO. Yeah, there we go. So this is now locked to the screen refresh rate. And OBS is losing some frames. And I think that's exactly what should be fixed with double buffering. Let's see if it's true. Yeah, that's exactly what I wanted. That's why double buffering exists. Because without double buffering, you can end up in a situation where you get like every second frame when both sides are synced to the same frame rate. And I'm surprised this is actually reproducing the failure I kind of expected, which is why I implemented double buffering. So this is cool. This means it works. You can see how it's getting every second frame there. And that happens when like the frames arrive with some like skew with a little jitter. So with double buffering, that gets fixed. Actually, I don't know if you're seeing it right because like there's... You're gonna be seeing some frames drop because of the whole HDMI capture pipeline I have here. I think you can mostly see it. Yeah, I think you can mostly see it. Okay. right, cool. So the only thing left now would be to implement the actual PipeWire explicit 6 stuff, but I think... Oh, this is a bug. Semaphore has not been destroyed. Let me just... Oh, yeah, because I killed it. I guess when you kill it, it just kills it. Did I just not free anything? I think I didn't free, like, the entire... Yeah, I need to do the freeing here. Or not? Is shutout even getting called? It is, okay. So we're missing some cleanup. Or are these my own? Wait, BK semaphores. Are these the funnel ones or the test ones? I think they are my funnel ones, so... Okay, it's not getting called. BK free buffer. Why is that not getting called? On remove buffer. Oh, did I just not call them? I think I just completely forgot to call the callback. Wait, no, it is there. Funk's free buffer. Oh, and this needs to be both of them. Did I not set it here? No, it is set the free buffer. Oh, I think it's possibly because... Oh no, I called destroy after all this stuff, so it should be in there. Does PipeWire not call the buffer free functions on stream stop? I guess it might not. Yeah, so it definitely calls buffer free, but not on stream destroy. So I guess PipeWire doesn't call this on stream destroy. I need some way to do that. Is this a PipeWire bug? Buffer, where's this? Clear buffers. Oh, that seems like a bug. That seems like a bug. Because it only does this on set param. And on used buffers, and that seems like a bug. Because then I need to like keep track of all the buffers that are allocated, which is annoying. That's annoying. That's not what I want. How do other implementations deal with this? I guess look at Kwin. It keeps its own track of all the buffers. All buffers DMA buff. Actually, is that an owning? Is that an owning list? That's a queue list of screencast buffer. That's just a list of pointers. So it can't be, it's not deleting anything. Well, I guess, okay, yeah, because I guess something like Kwin never destroy. Wait, no, hold on. If you close the window, it just does a stream destroy and sets mclose equals true. Doesn't this mean that Kwin is leaking buffers every time you share a window and then close it? Well, let's find out. 395, 396. Okay. Screen capture PipeWire. So if we pick the properties window, 428, 430. Okay, yeah, so there's some variation. And then it goes away for a 1. Oh, it is going up. It is going back. Okay, so it's not leaking. So why is it not leaking? Is it because this is an old PipeWire? 149. No, this is recent. Is it because I'm not setting the pause properly? Oh, maybe we need to drain it. but no, that's the source. This does not do set active. Yeah, this should be leaking if we are actually leaking. So why is it not doing that? There is an example. Let me just close a bunch of the stuff and go back to the PipeWire examples. So how does this finish? The cleanup at the end. Do quit? What's do quit? Just does main loop quit. Stream destroy. No. Oh, because I'm removing the listener first. It's because this needs to happen. It's because okay. I need to not call this. I need to not call this. That's why. Okay, that's why. Never mind. And now it's like false. It's sick faults and funnel buffer free. In funnel buffer free, it's calling a random function or something. in Bio Destroy. And because it's calling this in stream disconnect, I think I just have an ordering issue here. Yeah, I shouldn't be destroying DBM this early. There we go. And now we are I forgot to clean up some shader stuff. So Vulkan Semaphore, those need to be fixed later. That should work. And then finally, I can take off explicit stick support in the README. And this NVIDIA prop driver stuff, I think that basically means it's gonna need some weird stuff in the Vulkan flow. I forgot if I actually implemented this properly. The issue is basically that you need to declare this will have to be tested, but essentially it means you need to you do add format. It needs to check for the add format. It sets it as bit destination. and transfer destination. I think what you're supposed to do... I need to document this, but... I think it's supposed to work. And I'm gonna document this one as GL because it doesn't make any sense to do this for Vulkan. So my stream GPU just decided to... My stream GPU just decided to lose its context. How long was I gone? I think it wasn't very long. My GPU just timed out on the stream machine. Quite nicely, only OBS crashed. Even VTube Studio managed to survive. That's quite impressive that everything survived except for OBS. I guess I might as well pick up a core dump file. Am I still there? I think so. It's taking a while. Oh wow, the core dump function in Radeon is really slow. It's like extremely slow. What is it doing? It's like kilobytes per second. Okay, fine. Oh, it finished. Okay. Well, I'll have to figure out what happened there because that's kind of sad if that can happen. Thank you, Martin, for instant postmortem analysis. Yeah, I don't know. I'm gonna have to see if this is a known problem. It actually, so it seems like OBS itself. It's funny. It says the kernel log claims OBS caused the crash, but OBS itself has a message saying this CS is cancelled because the context is lost. This context is innocent. But maybe there was more than one context. I'm not sure. Ah, that's kind of sad. Anyway, I was going to say I'm going to add an API for checking whether rendering is efficient. So for Vulkan, I would just leave this to the user. So all this needs to be documented. Funnel modifiers. So in stream configure, I can probably just check for how does this work in add format? Modifiers, no modifiers. I can just put it in here and have a little flag in the config. If format, actually just if modifiers Yeah, that makes sense. And then explicit sync actually, that's not really ticked yet because what we really have is the fake explicit sync. What we really have is that, which is enough for Vulkan. Okay, that makes sense. I think we're done. I think I'm gonna call that a day. It's late, and I need to get some food, and I should be done. Okay. So yeah, we didn't get to the Spout2 thing just yet, but everything else is done. The Vulkan support is done. Only missing explicit sync support for PipeWire. Actually, do I want to just implement that? No, it's not. That's gonna be okay. The next stream is gonna be explicit sync on the PipeWire side, which should not take that long, and then Spout2. Okay, that was quite a bit. Make sure all my files are properly formatted. That makes sense. Good progress, good progress. All right. Any questions? Anything you want to ask before I call it a day? Yeah, this is looking good. This is looking good. So Vulkan support is now legit, even without explicit sync. Because now it actually works. So we only need to add explicit sync support now for the NVIDIA use case. Which means technically I could add support to like Godot already with this. Let me actually add the explicit sync stuff to the EGL example. Hello! I'm basically done.
Oh, did I eat?
No, I'll eat right after. I'm done. I'm just copying and pasting some example. You okay? There we go. That's explicit sync. All right. Let me check the comments. Next stream next week. Yeah, hopefully pretty soon. So next week will be Spout2. I need to integrate this whole Vulkan thing into the wine code base that we had before. Which is using EGL before, which is not the best thing to do. So a lot of copying and pasting between TestVK and the wine code, though a lot of this is going to go away because we don't need to render, so at least all the shaders and all that nonsense can just go away. We only need to do the blit, which makes it a little easier. And of course, no Wayland. So that's the plan. All right. I'm gonna call it a day. Thank you everyone for coming Let me just check the analytics. Oh, not bad. We got 141 viewers. Peak was like 180 or something like that. Nice. All right.
Yeah.
Kawaii. Cyan was like, this is this morning, right?
Yeah. And then there's more.
Aw, she's been drawing. So cute. Are you gonna post these?
Maybe, I don't know.
Maybe.
Let me check.
Oh. Oh, come on. This is too cute. Why are you so good at drawing?
There's more.
There's more.
Net?
It's so good.
I learned from the art book. I mean,
You should post these.
no, it's like I kind of borrow their ideas. It's not original.
Still.
I just switched the head to yours.
Oh, we should post them.
You can just look at it. There's more.
You're gonna make them wanna see them.
You can pick one.
You can pick one. What's going on here? Oh, so cute.
I really tried to draw R18, but I found myself too stressed. Why are you choosing this one?
Alright, thank you everyone for coming!
Thank you.
I'll see you all next time. Bye bye! Bye bye! Oh, right, right, hold on, my Python is very confused because I had to restart OBS. Let me fix that real quick. Okay, let's try that again. Bye bye! Bye bye! See you next time!